Alright, so we're going to look at section 8-4, which is talking about rate of change. For my second period class, you guys have notes. My 8th period with handing out report cards, I just forgot. But if you go to your online textbook and go to section 8-4 and then click on the resources tab, you can find the study guide and intervention. That's what I'm using as my notes. If not, you can just take notes on a separate sheet and follow along what I have on the page. So the first thing I have on here is just an example of finding rate of change. And rate of change is just talking about how one quantity changes as another one changes. Now, this ties into this section because we've been looking at X and Y values and talking about X is an independent and Y is dependent. So we've always been looking at how Y depends on what X is. So now we're going to look at, as X changes, how does Y change? So that's what we're looking at in this section. So the first example we're looking at is a graph. So you can see here that we have a graph starting at 0, 0 and running through 24, 8. So we have this line right here. And our rate of change is going to talk about, in our graph we're looking at the number of pages being read over some amount of time. So the top part is going to be the change in the amount of pages read. So from the beginning of the graph we've read 0 pages, and then by the end of the graph we've read 8 pages. So we're looking at the change in the pages read over the change in time. Now one thing to know here is that this top quantity, the changes in pages read, this is always going to be your Y values, and your bottom thing is always going to be your X values, because remember, we're talking about how one thing changes compared to the other. Well, it makes more sense to talk about how the dependent variable changes based on how the independent variable changes, or as how Y changes as X does, because we're going to control X and see what happens to Y. Now, if we look at this example, we have the change in the pages read. Well, from the end of our graph to the beginning, we read 8 pages at the end, and at the beginning we read none, so that's 8 minus 0, so that's a change of 8 pages. By the end of our line, we have read 24 minutes, whereas at the beginning of the graph we had read for 0 minutes, so 24 minus 0 gives us a change of 24 minutes. Now, if we simplify that, 8 over 24 simplifies to 1/3. So that gives me my rate of change. This group read 1/3 of a page per minute. So this is what we're looking at on this example right here. Now, what that means is that for every 1/3 of a page, we are spending 1 minute of time, and for every 1 minute of time, we're reading 1/3 of a page. So this is like the sequences that we saw in section 8-2, where as our X value increases by 1, our Y value is going to increase by 1/3. So there's our first example. Now let's look at another example. Alright, so if we look at example 2, now this is still finding rate of change, but the only difference is now we're looking at rate of change in a table. So if we look, here we have X values and Y values. Our X values we have are 0, 1, 2, and 3, and our Y values are 0, 2, 4, and 6. So we're still looking at change. Remember, the top one's going to be Y, so we're looking at a change in the Y's, which is our temperature, compared to a change in time. So for this, you can pick any 2 values. Okay, if I look at, say, these values right here at the end, I have my change in temperature is going to be 6 minus 4, because it's 6 degrees at the end, it was 4 degrees at the beginning. And my change in time, well, it was 3 hours at the end, but 2 hours at the beginning, so it's going to be 3 minus 2. So we have 6 minus 4 over 3 minus 2, so that gives me 2 over 1. So my rate of change here is 2, which tells me that my temperature is climbing 2 degrees for every 1 hour in this table. Alright, so let's look at some of the exercises down here. So here we're looking to find the rate of change for the linear function. So same thing, I have x's and y's. Remember, the top number is going to be our y, so we're looking at the changes in distance flown. So here at the end, I've flown 3,000 miles, but prior to that, I'd only flown 2,000. And then we compare that to the change in time. Well, at the end, I'd flown for 6 hours. Before that, I'd only flown 4. So I have 3,000 minus 2,000, which is 1,000. Over 6 minus 4, which is 2. And of course, 1,000 divided by 2 gives me 500. So my answer is 500 miles per hour is our rate of change. And if you look, you can see that because our distance goes from 0 to 1,000, but that's in a change of 2 hours. So that means it goes from 0 to 500 in 1 hour, from 500 to 1,000 in the second hour, from 1,000 to 1,500 in the third, from 1,500 to 2,000 in the fourth. So you can see it is climbing. It has a constant rate of change. It's climbing by 500 miles each hour. Now we can do the same thing with our graphs down here. The cookies needed, well, let's see. Our rate of change, this time our y values is the cookies. So what goes on top is going to be the number of cookies, and what goes on the bottom is going to be the number of people, or the change in cookies, number of cookies, or change in people. So if we look at our graph, we can pick any 2 points that are on this graph. So let's say I'll pick this one. We want to pick neat ones that are, on nice, neat vertices. So we'll pick this one, and 0, 0 is always an easy one to use if it's on there. So I have the number of cookies is 40 at the end, but the number of cookies at the beginning is 0. The number of people at my higher point is 8 people. The number of people at the beginning was 0. So I have 40 minus 0, which is 40, over 8 minus 0, which is 8, and 40 divided by 8 is 5. So our answer for this one is 5 cookies per person. So our rate of change is 5 cookies per person. Alright, so we have one last one to do in our exercises. Here we're looking at sales. So again, I can pick any 2 points. So just to make it easy, we can pick this point at the top and this point at the very bottom. Now for this, we're going to look at our rate of change. The items sold is my y, so I'm going to look at the change in how many items are sold over the change in the price. So my items sold, I have 12 at the end and 36 at the beginning. So I have 12 minus, sorry. I'm doing this wrong, sorry. If we're looking at this, the item sold is our y value, so our y value goes from 36 to 0. So I have my item sold is 0 minus 36. Now we can also do 36 minus 0, but if we do that, we need to understand that we also need to do the x value that matches with 36 minus the x value that matches with 12. You can subtract them in either order as long as you are consistent. So if I do this up here for my items sold first and this one second, then this up here needs to tell me how my price is, which my price starts at 0 here, and my final price would be the 12. So if I have 0 minus 36, so I'm doing the second value minus the first value, then I'd have 12 minus 0, because that's the difference in our x values. My x value of my second point is 12. My x value for my first point is 0. So I end up with negative 36 over 12, which simplifies to negative 3. So in this case, we have a negative rate of change because the amount of items sold per dollar is going down. So those are some examples looking at rate of change. Now, if you look on the next page of your study guide and intervention, in the back, if you have the paper copy, or if you're looking online, you can just slide down to the next page in your document. We have some interpreting rate of change. Now, all this is looking at is comparing two different rates of change. So here we have two graphs. We have one graph that shows Layla's heart rate, and we have one line that represents Joseph's heart rates during the 3 minutes after they exercise, and we can compare their heart rates. So, remember, our rate of change is always going to be our change in our y values, which our y values in this problem represents our heart rate, over our change in our x values, which represents minutes, which we know is from 0 to 3, since we're looking at the 3 minutes after they exercise. So, if we look at Layla is the bottom graph, and her graph starts at this point right here, which is about 135 is the y value, and in the end she ends up at about 65. So there's where we have our 135 minus 65. So looking at this as my first value and this is my second. So then for my x's, my x here, which is the number of minutes, is going to be, we're going to look at our rate here. So here, and actually in this example, they actually don't come up with a negative value. They really should, though. This is really a negative rate of change. They're just talking about what rate it changes, but I like to think of it as negative because the heart rate is decreasing. So the reason it'd be going down is because if we're looking at her heart rate comparing this first value right here, the 135 minus this one, the 65, then this first one is at 1 minute and the second one is at 3 minutes. So we would have not 3 minus 1 like they have, but I would have 1 minus 3, which would give us negative 2. So the rate of change would be negative 35 beats per minute. Now, in either way, you're changing by 35 beats per minute. The negative just lets us know that the heart rate is going down 35 beats per minute instead of going up. Same thing if you look at Joseph's heart rate. Joseph's heart rate starts at 160 at the first minute, and it goes down to about 70 at the end. So we have 160 minus 70, which gives us 90. Then, again, they put 3 minus 1, but I would think of it as 1 minus 3, because I'd look at from the first moment to the last. So 1 minus 3 gives us negative 2, which gives us negative 45 as a change, because his heart rate is decreasing by 45 beats per minute from the first minute to the third minute during the first 3 minutes after exercise. So Joseph's heart beat decreased at a greater rate than Layla's heartbeat, because his was decreasing by 45 beats a minute, whereas Layla's was decreasing at only 35 beats per minute. Now, if we look at the exercises on this page, again, it's the same thing. We're still looking at rate of change. We're just looking at two rates of change. We're looking, for instance, in example 1, Ned boiled 2 beakers of water. He put 1 beaker in a pot of cold water to cool, and then he compared the temperatures of the 2 beakers to see how much faster the one that's in the cold water would cool off. So, comparing the rates of change, all we have to do is find the rate of change for beaker number 1. And again, you can pick any 2 points, so I'm going to use the first 2 just to make it easy. So beaker 1 goes from 100 degrees Celsius to 96 degrees Celsius. Now those are my Y values, whereas my X values from there is from 0 to 1. So 100 minus 96 gives us 4, 0 minus 1 gives us -1, so we have a decrease of 4 degrees per minute in our first example. Now, if we look at beaker number 2, we have the same X values, but our Y values are not changing in the same way. If you look at from 0 to 1, we actually have no decrease in the temperature. But if you look from 0 to 3, we're going to see a change. This is because this one's not changing at a constant rate. It's decreasing. But if we look, say, from 0 to 2, so if I do 0 to 2, I have 99 and 100. So 100 minus 99 over 0 minus 2. 100 minus 99 gives me 1. 0 minus 2 gives me -2. So this one looks like it's changing by about half a degree per minute. Now again, this doesn't have necessarily a constant rate of change. It may cool more slowly at first, and as it starts to cool, gradually start cooling off a lot faster. But if we just go by looking at 2 points, we have there a rate of change of about a half of a degree per minute. Now let's look at this last example. So for the last one, we have 2 cars. They accelerate from 0 miles an hour, and we're going to look at which one accelerates faster and talk about their rates of change. So car number 1 goes from 0 to 60 in just 8 minutes. So our rate of change, now our Y value is our speed. So we end up at 60 and we started at 0. That's our Y values, 60 to 0. And then our X values went from 8 to 0. 8 seconds, starting from 0 seconds. So we get 60 over 8, which gives me 15 over 2 when I divide by 4. So our rate of change here is 15 over 2, and we're going to leave it as an improper fraction instead of changing it to a mixed number. And we'll talk about that a little bit more when we get into writing equations. So this has a rate of change of 15 over 2. So its speed is increasing by 15 miles per every 2 seconds. Now, the next one, if we look at the second car, it also starts at 0, 0, but it goes to only 40 miles per hour after 8 seconds. So 40 minus 0 gives us our change in its speed, but 8 minus 0 gives us a change in the amount of time. 40 divided by 8, of course, gives me 5. So this one has a rate of change of 5 miles per second. So, looking at this, 15 divided by 2 is 7.5. So if you were to look at it as a decimal, one car is increasing by 7.5 miles an hour each second. The other one is only increasing by 5 miles an hour each second. So that's how we would be comparing rates of change. You just look at the rate of change for the first, the rate of the change for the second, and then you can look at, okay, which one has a greater rate of change. Now, I promised my 8th period that we would look at one example from the homework. So if you want to look in your homework at the skills practice question number 1, we'll do that one together here. So here we have example 1, the first question on your skills practice in your homework. Now, I am doing it for you, but you still have to copy it down to get credit for it. So don't assume that just because I'm doing it for you, you automatically get credit. So for here, we want to find the rate of change, and to find rate of change, that means we need 2 points that are on the line to talk about how it's changing. Like I said, if you ever have 0, 0, that's a really nice, easy one to use. And then you can pick any other point as long as it's a pretty point. Don't pick something that's in the middle. You want to pick something where 2 lines meet. So for instance, I can use this point right here, which is 612. So my rate of change here would be the change in the amount of milk, because that's my Y value. So the amount of milk at the end is going to be 12 liters, but at the beginning it was 0. So I have 12 minus 0 over the change in weeks, which at the end, my final week is week 6, but at the beginning it was week 0. So I get 6 minus 0. So 12 minus 0 is 12. 6 minus 0 is 6. 12 divided by 6 is 2. So we get this rate of change. The amount of milk is increasing by 2 liters per week. So that's how we do the rate of change problem. So for the rest of your homework, you need to complete questions 2 through 6 by finding the rate of change for each table or graph. And then we will check these in class tomorrow and then talk a little bit about the difference between just rate of change versus constant rate of change on Monday.